So our topic for today is Newton's laws of motion. So as all of us know, Newton has proposed three laws of motion. The first law of motion, first law, first law. Can anybody tell me what is the first law of motion?
Vector sum of all
Vector
forces is
sum,
zero, then acceleration zero.
vector sum, vector, no, nothing related to vector. Nothing related to vector. First law is nothing
If
related to vector.
force applied is zero, acceleration zero.
A body will be at rest or in motion.
Every material body persists. Whatever you are telling Debojyoti, that is the mathematical representation of the Newton's first law. Understand? But the statement of Newton's first law is something different. It is every material body persists in its state of rest or of uniform motion in a straight line. Motion in a straight line. If and only if it is not compelled by an external force to change that state. This is the first law, that every material body persists in a state of rest or of uniform motion in a straight line if and only if it is not compelled by an external force to change that state. This what Devojyoti told that yes, if there is no force, then the body will remain in its state of rest. Acceleration will be zero, right? So that will be coming from the second law. That will be coming from the second law. Second law of Newton. The statement is the rate of change of momentum of a body. The rate of change of momentum of a body is proportional to the impressed force and takes place in the direction of which the force acts. From here, one important point is momentum. Do you know what is momentum? Do you know what is momentum?
Mass velocity.
Mass into velocity. That is again a mathematical representation of the definition. Momentum of a body is the property by virtue of which it possesses a motion, right? Momentum of a body is the property of the body by virtue of its motion. If a body is in motion, it will have a property inside it known as momentum, right? And it is given or expressed as the product of the mass in velocity, right? And third law, everybody knows, to every action there is an equivalent. To every action there is an equal and opposite reaction. So based on these three laws, we will discuss our chapter. So from this, one important point is that every material body persists in state of rest or of uniform motion in a straight line. Means a body will try to remain in its state of rest or of uniform motion in a straight line. So that has to be some concept behind this, and that concept is known as inertia. That concept is known as inertia. That concept is known as inertia, right? So the inertia of a body, what is inertia of a body? Inertia of a body is the property, inertia of a body is the property, right, which tends to resist a change, which tends to resist a change in its state or motion, right? This property of the body will try to resist the change in its state. Suppose if a body is at rest, the body will try to remain at rest. Even if some force is applied to it, it will try to remain at rest. And what is if a body is in motion, it will try to remain in motion, and it will oppose any force which tries to stop it, right? For example, there are two types of inertia: inertia of rest and inertia of motion. What is inertia of rest? Inertia of rest is the property of the material bodies to persist in their state of rest. Inertia of a body is the property of the body to persist in their state of rest, and inertia of motion, it is the property of the material body to persist in their state of uniform motion in a straight line, right? So what are the examples of inertia of rest that you come face to face with in your daily life? Suppose you are moving in a bus, right? You are sitting in a bus and the bus suddenly starts, right, with a jerk. What happens? Your feet were in contact with the floor of the bus, right? So they moved with the bus. But the upper part of your body, right, it was not in contact with the bus floor of the bus directly. So it tried to remain in its state of rest, right? It tried to remain in its state of rest. So you are pushed backwards. So you are pushed backwards, right? Similar case happens when suddenly the bus is moving, and suddenly it presses the brakes. Then what happens? The bus comes to a stop immediately. So your feet, which were in direct contact with the floor of the bus, they came to rest immediately. But what happened to the upper part of the body? The upper part of the body continued in its state of motion, as it was not in direct contact with the floor of the bus. So you are pulled forward, right? So that is inertia of motion. That is inertia of motion. You may sometimes see that uh, when you take out your coat or your old clothes from your cupboard, you dust them with a wand or a stick, right? So what happens? Why do you dust them? When you beat the clothes with the stick, what happens? The clothes moves in motion, but the dust particles, they tend to remain at rest, right? They tend to remain at rest, so they fall down. Are you getting my point?
Yes.
Yes, sir.
Okay.
Yes, sir.
So that were the examples of inertia of motion and inertia of rest. Next definition that will be very important will be the definition of force. What is a force? What is a force? Force is that which changes or tends to change the state of rest or of uniform motion along a straight line, right? Force is that which changes or tends to change the rest of the state of rest, sorry, the state of rest or uniform motion along a straight line. Understood? Now, first law, it is just doesn't have any mathematical importance. The most important is the second law, Uh, so second law, what it tells you? Second law tells you that force, let force be P, sorry, the rate of change of momentum is directly, so P is proportional to, let me draw the sign, 3, force P is proportional to rate of change of momentum. So if the initial velocity was u and the final velocity was v, right? So initial momentum will be mu and final momentum will be mv. So it will be mv minus mu divided by time, right? Rate of change of momentum, rate of change of momentum, right? So we can write P proportional to M V minus, sorry, V minus U by T, right? And this you can write P proportional to M acceleration A, because acceleration was V minus U by T. So P proportional MA. So we can write P is equal to a constant K into M into A. Now, for a unit force, if a unit force is acting on a unit mass, the acceleration is unity. If a unit force is acting on a unit mass, then acceleration is unity, which means P is equal to 1, M is equal to 1, A is equal to 1. So K is equal to 1. So we can write P is equal to M into A. This is one derivation of P equals to M into A, right? You have an alternative method by calculus. I am doing that calculus method also because I have taught you calculus, right? Important differentiation I have taught you, right? Differentiation I have taught you. Have I not taught you?
Yes, yes.
So now, if I take momentum, momentum is given by small p. Momentum is equal to mv. Momentum is equal to mv mathematically, right? So if rate of change of momentum will be dp dt, rate of change of momentum will be dp dt, right? dp dt. That will be equal to ddt of mv. Very good. ddt of mv, and you know m is a constant, so m will come out, right? And it will be only ddt of v. And what do you know dv dt? What is dv dt? Acceleration. What is dv dt? Acceleration, right? dv dt is acceleration, है ना? So force is proportional to this. Force is proportional to this. P is equal to ma. Understood? Okay. So units of force, do you know what are the units of force? The units of force, Newton in SI or MKS system, dyne in CGS system, and poundal in FPS system, foot pound second system. It is poundal, 1 foot per second square, 1 foot per second square. Okay, pound into 1 foot per second square. Relation, do you know the relation between Newton and dyne? Do you know the relation between Newton and dyne?
10 to the power 5.
10 to the power 5, right? 1 Newton is equal to 10 to the power 5 dyne. 10 to the power 5 dyne. You can easily do it. What is 1 Newton? Force. What is force? Force is mass into acceleration. Mass into acceleration means mass is kilogram. Mass is kilogram. 1 kilogram. And this is meter per second square, right? So now you convert 1 kg to 1000 gram. 1000 gram into 100 centimeter. per second square. So this gives you 10 to the power 5 gram centimeter per second square, and that is equal to 10 to the power 5 times. Okay, remember this unit, it will come. Okay, in some problems you may see that it is written that the force is 1 kg weight. Force is 1 kg weight. 1 kg weight means is this weight is written, it is gravitational units. So 1 kg weight is equal to nothing but 9.81 Newton, or almost equal to 10 Newton. Okay, nothing else. Just they have multiplied 1 kg with 9.8, the value of acceleration due to gravity G. Understood? So either you can take 9.8 Newton or you can take 10 Newton. No problem. So you do one problem and we will see how you have fared. A very simple problem. A force acts on a 10 kg mass. A force acts on a 10 kg mass and increases its velocity from 5 meter per second square to 10 meter. Find the force.
10.
आपने लिखे थे velocity meter per second square.
Oh, my mistake. Thank you. Everybody, the answer is 10 Newton. Have you got? Answer is 10 Newton. Answer is 10 Newton. One data was missing.
So the 5 say,
Data was missing.
Oh, yes. 10 Newton.
10 Newton. Okay.
and
So next we are going to learn impulse. The next topic in our discussion is impulse. Have you heard this term, impulse? So what is impulse? You might have come across this term impulse. So impulse of a constant force, acting on a body is defined as the product of the magnitude of the force, and the time during which it acts on the force. For example, everybody watches cricket here. Everybody watches cricket here. So when a bowler delivers a ball, right, and the batsman hits it. So just when the batsman hits the ball, the contact between the ball and the bat is of very small time, is of very minute time, is for a very minute time, right? And for that time, and the force with which he hits it is of very high magnitude. So impulse is of a constant force is the product of the magnitude of the force. This force is of very high magnitude, and the time during which it acts on the force is of very small duration, right? So when a very heavy force or a very high force of very high magnitude acts upon a body for a very small time, then it is known as an impulse, right? Then it is known as an impulse, right? Impulse. Did you got my point? When a very force of very high magnitude acts on a body for a very small time. Understood? That is impulse of a force. Now what is an impulsive force? That was an impulse of a force. Impulse and impulsive force are two different things, right? That was impulse of a constant force. Now impulsive force is a force of very large magnitude but of extremely short duration, that I told you, right? Impulsive force is a force of very high magnitude and but for extremely short duration. Extremely short duration. As I have explained in the example, when a cricket ball is hit by a bat, right? Which acting now, what happens to this? Of very high magnitude but for extremely short duration. Now, which acting on a body, produces a finite change of its momentum. Finite change of its momentum, right? So this force will produce a change in momentum, right? Finite change of its momentum. Also displacement of the body during the action of the force being negligible, right? Displacement of the body during the action of the force being negligible. Understood? Have you got my point? So you might have been, sir, the ball moves in, the displacement of the ball is very high, na? When a cricket bat hits the ball, the displacement of the ball is very high, right?
Yes.
But it is saying the displacement of the body during the action of the force being negligible. What I told you and what it is written here is C. Displacement of the body during the action of force being negligible. As I have told you earlier, the force acts for a very short duration, and for that duration, the displacement of the ball is negligible. But after the force has been exerted on the ball, the displacement of the body is very high, right? Got the point?
Yes.
Yes. And for third law, I don't have anything we have to discuss. You know, to every action there is an equal and opposite reaction, right? To every action there is an equal and opposite reaction. So if you give a force on a body, the force will be exerting another force on your body. For example, when you pull, when you are carrying a suitcase in your hand, right? You are giving a pull to the suitcase, right? And the suitcase in turn is pulling, giving a pressure or giving a force on, exerting a force on your hand. That's why your hand aches now if you are pulling a heavy weight for half an hour, you feel your hand is aching. That's why, because the suitcase is also exerting a force on your hand. Understood? So that is it for this class. We will start our next class in 5 minutes. Okay.